So, circumcenter. What's a circumcenter? How do you find it? It's where what? It's where the perpendicular bisectors meet. Okay. What's the characteristic of it? Like, how do you know you have a good circumcenter? What should happen? Should the circle be on the outside or on the inside? Should be on the outside. So you find it by doing the perpendicular bisectors. So you have this line here. You find the midpoint. You have this line here. You find the midpoint. Roughly, looks like pretty much a right angle. So you have this one here, and then that circumcenter should be the same distance to all 3 points. Yes? It's a very good circle, isn't it? All right, so what's a in-center of a triangle? So you find it where the angle bisectors meet, right? Okay. And then how do you know you have a good... So you bisect this angle, looks like about there. Bisect that angle. Bisect that angle. And what should happen? You should be able, the distance to all 3 sides should be the same. So your circle should fit inside the triangle. Yes? You know, if you think you can draw a better circle, you're welcome to. All right. A couple days ago, oops, fumble. We talked about our next one. Remember what it's called? Find the centroid. What? It's not the midpoint, but you have to find the midpoint, and then what's that line called? What's it called? Where you find the midpoint of a side and connect that midpoint to the opposite vertex. That was interesting.
I don't think that's it.
Wait.
What is that line right there called? Somebody said it. No. Median. Okay. So I heard it somewhere. You find the midpoint, right? You connect the midpoint to the other side. You find the midpoint. You connect the other vertex to the midpoint. And those are called medians. Where the 3 medians meet, that's called the centroid. And what were the 2 interesting characteristics of the median? Or the centroid. One was the balancing point, right? Where you can balance the triangle. If you put your pen at that point, it should balance. And it's the what? Remember, if you know this distance here is 4, what is that distance there? 8. And then if this distance here is 3, what is this green distance up here? 6? Yes? And then what if I told you this whole distance from here to here, we'll call this A and B. If AB is equal to 12. Well, I don't do 12. Let's do 9. No. All right, 6. If that whole distance is 6, and we'll call this C for centroid, how would you find BC, or how would you find AC? If the whole thing is 6, how would you find the 2 parts of it? if this is x, what's this got to be? 2x. So x plus 2x should equal the whole thing of 6. X plus 2x is 3x. So x is 2. And then if this is 2, that's got to be 4. Simple? All right, so we have 3 of our 4 centers of triangles. We have circumcenters, where all the perpendicular bisectors meet. We have incenters, where all the angle bisectors meet. And then we have centroids. Are we good so far? Because now we got a 4th one. 4th one is called an orthocenter. Okay? Now, has anyone ever heard of an altitude? What's an altitude? What do you think, Mally? Mally. Mally. It's more fun to say Mally.
Anyway, it's how high you are off sea level.
All right, so if you're like flying a plane, all right, here's my plane. Thank you. If you're flying a plane and you're flying a plane and you're on an altitude of 4,000 feet. What is that? How do I label that distance? Yeah, but how would I draw the altitude?
Draw a big old line connecting that to that. Oh,
Okay. Draw a big old line from the plane.
Yeah, all the way down to the water.
Like this.
Yeah.
No. Straight down.
Oh, it's got to be straight down. Oh, it's got to be a right angle with what? With the ground. All right. So that actually, with an altitude, that right angle, that's the most important part. So it has to with the opposite side. Okay? So what an orthocenter is, an orthocenter of a triangle is where all 3 altitudes meet.
How does a triangle have altitude?
Okay? Triangle has 3 altitudes. So there's 3 different ways. So I take this vertex and I have to connect this vertex with the opposite side with what kind of an angle?
Right.
With a right angle. So this one's actually pretty easy. That is one of the 3 altitudes. Make sense? Now, from this side, it gets a little bit, from this vertex, it's a little bit different. Because again, I have to connect that vertex with this opposite side with a right angle. What do you mean by that? Yes. So obviously, it's not going. Where is it going to connect with this line? Is it going to be somewhere over here to make a right angle? If I were to draw that from that vertex to here, would that be a right angle? No. So what I actually have to do is I have to extend that line. Get that a little closer. Okay, out a little bit. This, so that it forms a right angle. That's another one of the altitudes. So this is an altitude. That's an altitude. And then I also have to be able to do it to this point. And again, I have to be able to connect this vertex with which side? That top one there, right? So I have to be able to connect that one with this with a right angle. So it might be right there, or I may have to extend that out a little bit. And then this would be an altitude. Okay? Now, in this particular case, if I were to blow that up a little bit, where do you think approximately the orthocenter is going to end up being? Where will this blue line, this white line, and this purple line all intersect? Yeah, it's going to be, somewhere about here. Yes, I mean, you got to extend that line, you got to extend that line, extend all three of those a little bit. But this is going to end up being the orthocenter. Make sense? So it's a little bit of a harder one to draw just because you have to find these three different altitudes. Okay? And what's the most important thing about the altitudes? Right angle. Now, the orthocenter is actually probably of the four centers, the worst of the four, as far as the most useless one. It really is. There's really not a whole good use for it, other than there's a kind of a pretty cool characteristic. So we'll call this ABC, triangle ABC, right? Come on. No, there actually is not a circle involved. All right, so this is triangle ABC, and we'll call this point O for the orthocenter, right? Here's the cool thing about orthocenters. In fact, let's just do one kind of for real. I'll show you. All right, so we're going to go like this. Actually, no. I want to do this first. Make it a little easier to see. Let's construct one. We're going to go like that. We'll go there. So there's our triangle. Okay? Call it a triangle ABC. I have to find the altitude of one side. Which angle, which vertex you want to start with? A? Okay, good idea. I have to be able to connect this vertex with which side? BC with a right angle. Okay? What am I probably going to have to do with side BC? Yeah, I'll probably extend it out a little bit. I'll just draw that out like that. Okay? And then I have to be able to connect this and that with a right angle. So here's the easiest way to do this. You take your compass, put it at the intersection point. What you first... I may have to make this a little smaller here. Oops. Come on. Select. Make that a little smaller. A little too big for me. Alright, so you gotta take your compass, put it at one of the points, and what you want to do is you want to open it up to where it will intersect the line. Like right now I'm a little too small, but it'll intersect that line. And what you want to do is draw that line so that it'll intersect twice. Okay? Would you agree that this point here and that point there are both now the same distance away from A?
Yeah.
Okay. So now all you do, take your compass, open it up to that point. You can change the size of your compass, and you swipe an arc. Go up to the other point and swipe the arc. I missed, didn't go far enough. Now, once you have that, what do you think is the only thing I have to do? Draw the line. So I can connect the dots from vertex A through that point. This here is a right angle. Agreed? If you did it right, that should be a right angle. Okay. So now all I have to do is another side. Let's do side B. First step. All you have to do is What's that? Nope. All it has to do is intersect twice. Cool? What's that? It could have been smaller, or I could have extended, made it bigger, but now all I have to do, find where it intersects, swipe an arc somewhere through there, come over here to this other spot it intersected, swipe that arc, and then connect the dots. And I should have a right angle there. And then what I can do is I can extend that through there. Do I already kind of know where my ortho center is now? What's that?
None.
How could I check to see how good of a job I did? Do the third side. I mean, I should do the third corner. I should come over here to C, swipe that arc so it crosses. What am I going to have to do with this line here? Extend that through there. Okay. That's a long ways, but all right. Swipe that through there. Cross my arcs. Come over to here. Cross that arc. And then last thing I have to do, connect the dots, right?
That's a lot of lines.
It is a lot of lines. I'd say I did a pretty darn good job. So you have 3 lines.
Where are the 3 lines?
I don't know. You have 4 points. You have point C. You have point C right here, right? You have point A right there. You have point B right there, and then we're going to call that point O for the ortho center. Yes? Now, almost got rid of everything. Here's the nice thing about the ortho centers. No, I don't want to do that. What happened to my O? Oh, it came with it, didn't it? All right, get rid of that. No, undo. I don't want to get rid of that. I just want this. No, I can't get rid of that. Can I get rid of these? How about this thing? Get rid of that. Can I get rid of this? No. How about this? Oh, it's all connected. Okay, so you have these 4 points. You have point A, point B, point C, and point O. Yes? All right. Here's the cool thing about ortho centers. If you... Is it going to let me do it now that it's not connected? No. I can't. It won't let me erase it.
You erase that line.
Oh, I guess I can. All right. So I have these 4 points now. Here's kind of the cool thing about ortho centers. Is if you take 3 points. So let's say we connect and draw a new triangle. ABC, we'll call it COA. What do you think point B is going to be?
The thingy that's
That's going to be the new ortho center. If you draw the triangle AOB or CBO, guess where the ortho center is going to be? Point A.
It can be like all the way over there.
It can be all the way over there. And it will be all the way over there. These are called ortho systems. They're kind of useless, to be honest with you. But what it does is it creates these 4 points where no matter which of the 3 points you pick, the 4th point will then be the ortho center of that new triangle. So it's kind of cool. Like they're all intertwined with each other then. Other than that, yeah, they're kind of useless. Okay? All right, so take out your homework. You guys did page 340, number 11 and 12, right? What? No, it was on. I gave you the graph paper. You plotted the point. Yeah, sophomores weren't here. So sophomores need graph paper.
What? We had a whole
Yeah, we did 11 and 12 together. Sophomores, raise your hand if you weren't here on, was that Tuesday?
What? And then what you heard.
Okay. So we did 11, 12, and 20. So sophomores, you have to do 11, 12, and 20.
Wait, are you going to give us number 11 and 12?
We're going to, I'll just talk you through it a little bit. But I want to talk about number
Wait, what page?
15 first, 340. So everybody on 340? And I want to look at number 14. Okay? So everybody plot those points. Number 14. So they give you, what, 3, negative 2. That's point J. They give you 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's K. And 9, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 2. And that's point L. Please plot those points.
I'm going. Well, it's the size. It just whoa. It just won't go in.
Now, what it's asking us to do in this one is to find the orthocentric. Now, there's a couple of different ways. There's a couple of formal ways to do this. But for us, to find this orthocenter, what do we have to draw?
A triangle.
Where's the orthocenter located? Where what intersects?
The 3, whatever they are.
What are those called? Altitudes. We've got to draw the altitudes. So let's start with the easy one. JL is a horizontal line, right?
Yeah.
So what kind of line is the altitude going to be?
Vertical.
Vertical line. Isn't it going to go through K and just be a vertical line?
Yeah.
Great. Draw that. So it's going to start at K, and it's just going to be a vertical line that goes right straight down from there.
Can we use the same for J?
Well, to find the altitude that goes from line L, from here, how does it have to intersect with KJ? Has to be a what? What's the most important thing about an altitude? Right angle. What do we know about lines that intersect at right angles?
They're 90 degrees.
What else do we know?
They're
Do we know anything about perpendicular slopes?
opposite reciprocal.
They're opposite reciprocals of each other. So can we find the slope of line KJ? How do you find the slope? You could use the slope formula, or you can just count. So from here, what's the rise and what's the run? We go up 1, 2, 3, 4, 5, 6, 7, 8 over. So up 8 over 2. So the slope is 4. So what does that mean about the slope of that altitude? What's the slope have to be? What's the opposite reciprocal of 4? Negative 1/4. So what that means is I can start at which point? It's going to intersect JK, so it's going to start at L. Okay, start at L, and I count. I can go down 1 over 4. Or I can go up 1 and back 4. 1, 2, 3, 4. And then I can draw that line. So it basically go right through there. Make that a different color. So far, so good? Now, do we have enough information to say where the ortho center is? Yeah, I mean, it's technically it's right there. So what do you think the coordinates are?
1, 2, 3, 5, -1.
5, -1. So we think the answer is 5, -1. Could we do something to double check it?
Oh, yeah, make an example.
Or you could just find the slope of what? What's the slope of KL? Well, how do you get from here to here? You go down 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4. So down 8 over 4 or -2. So what does that slope mean about the slope of that altitude? Positive 1/2. So from what point should I be able to count up 1 over 2? Which vertex intersects with KL? Where do I start? Point what, J? So from here, I should be able to go up 1 over 2. So yep, up 1 over 2, up 1 over 2. So this would be. So again, yep, looks like it intersects at 5, -1. Make sense? There's other formal ways to do this. That's the easiest way I know of to do it, though. Just find the slope of each side, count from the other vertex so that it intersects that with a right angle. Try the next one.